topic of discussion will be soil structure and clay mineralogy, and this is the part of the first unit only, where we are discussing various index properties and various other things. So, the very first topic will be the soil structure, and then we will move on to the clay mineralogy part. So, as observed in nature, there are different structures, and the soils are arranged in different structures. So, what is the type of structure? What if there are similar kind of particles, that is similar grain size? What if there are a mix of a coarse grained and fine grained, then what kind of structure is there? So, we will be discussing those two things here. So, in this soil structure topic, see here, the geometric arrangement of the soil particles or mineral grains as well as the interparticle forces which may act between them is referred to as the soil structure. So, remember here one thing, that first of all we will be discussing what type of structure, but there are also some forces which will be acting in between the particles, or the particles would be exerting on the other ones, on the other particles also. So, studying of this behavior will be constituted into two forces: the behavior of the individual soil particles and their interaction with other particles is influenced by the following forces. That is, the very first thing here it is, what? Weight of the particle. If we consider a soil, which contains some particles, some bigger particles, so this, the above one will be exerting a weight, a simple force on the lower particles, that will be its own weight. Similarly, the other particle will also be, subsequent lower particle will be getting subjected to some force, that is the weight. Similarly, if there is some other particle, so that will also be subjected. Second thing, note here that the very first thing is what? Weight of the force, that is due to gravitational force. Each and every body is subjected to what? Gravitation on the earth. So, the very first thing will be gravitational force, that is due to the weight. Next is the particle surface forces. Each and every particle, though each and every particle will have some surface forces, but most predominant ones, the surface electrical charges, the positive or negative signs, like say a clay mineral will having some charges either plus or minus or both. So, these surface electrical charges are in a way affecting the interparticle forces. So, you have to understand here that these particle surface forces will be influencing how the structure is arranged. So, we will be looking on to this thing, particle surface forces, but keep one thing in mind, that these particle surface forces will be predominant in the fine grained soils and not in the coarse grained soils. So, see here the next point, for the larger size particles which include the soil particles in the coarser fraction, that is, we have already studied in the last class that if there is a 75 micron sieve and the particles are retained over it, so it will be denoted as coarse fraction, and if the particles are passed on from or passing the 75 micron sieve, that will be what? Fine grained soil. So, here also we will be talking about the coarser fraction and the finer fraction. So, the coarser fraction may include what the type of particles? Gravel or the sand, those we have discussed, or it may contain cobble or boulder. So, these are all what? Bigger particles. Bigger particles, they will have some weight, and the weight which they will have, they will be like acting on the subsequent lower particles because of their own heavy weight. So, the surface electrical charges may also be there, but in that case the gravitational force will be more than the surface electrical forces. When we consider this second part, the smaller particles, see here, for smaller size particles, the surface electrical forces, that is Fs is predominating. If Fs is predominating, then over what? It is over gravitational force. So, here Fs is more than what? Fs is more than what? Gravitational forces which act in there. So, when we are talking about the coarse grained structures, we will be talking about what kind of force? It will be gravitational force. When we are talking about this smaller size particles, we will be talking about the surface electrical charges which are present on them and how do they interact or behave or change the properties. Now moving on to this, as per Terzaghi and Casagrande, soil structures can be classified into single grained structure or honeycomb structure, or the third portion is what? Flocculent and dispersed structure. So as the name suggests, it is single grained, so we will be seeing how these are single grained, then how it will be placed in a, how will the arrangement will be. When we talk about this honeycomb, so honeycomb, as the word says what? Honeycomb, that means it contains some type of voids. Honeycomb, like the honey bee makes its comb, so it contains what? A large number of voids. That kind of structure will be here also. As the name suggests, we will be looking on there how it is honeycomb and how it will be occupying or containing some voids. Then the third one is this flocculent and dispersed structure. Flocculent means what? It is maintaining or containing a flocks. Flocks means they are all together. They are all together, very near, making a heap or flocks. But how is the flocculent structure? We will be seeing that thing. Next is the dispersed. Dispersed means they will be slightly away. How they will be away? We will be seeing that thing. So these are the three classifications: single grained, honeycomb and flocculent. But these are related to a particular size. This will be corresponding to a particular size. This thing will also be corresponding to a particular size, and similarly the flocculent and dispersed, that will also be due to a particular size. And remember one thing here, that each and every structure will be having some amount of the gravitational force or the surface electrical charges. So what they will be and what will be their effect, we will be talking about that in the subsequent slides. The very first thing here, see, when we are talking about the single grained structure, the structure is found for soils which are greater than what? Greater than 0.02 mm size, that is sand and silt particles. So if you are talking about some bigger particles or larger particles, what happens there, that each particle is in direct contact. Each particle is in direct contact. See here, direct contact, we will be talking about this thing with the adjoining particle. Due to the effect of what? Gravitational force. That is, there will be, of course, there will be surface electrical charges also. There may be some charges here also, or here and then here also. But the thing is, the gravitational force due to large size of particles will be predominating. So we will be more as compared to the surface electrical forces. So we will be considering what? The gravitational force and not the surface electrical charges, though they may be acting, but we will not be considering that thing. So see here, this one will put its weight here, then this will also be putting some weight here, this one will also be putting some weight here. So this single grained structure is into this unit volume or this volume, whatever be this volume. So these are packed in this entire volume by their effect of their own weight. Next we will be moving on to the honeycomb structure. In this, it is found for the slightly smaller particles, that is, the structure is found for the soils having size between what? Between 0.2 mm and 0.002 mm. So these are there, and it will include what? Smaller than the previous stage that we discussed about, that is fine sand and silt. Here, remember here, in this is just in the previous case we discussed that gravitational force was dominant. Here we are discussing that both the gravitational force and surface electrical forces are equally important. So both are equally important. Both gravitational force and surface electrical forces play equally important role in the formation of this structure. Now how do they do this thing? What happens when the soil solids settle under the effect of their own weight under deposition, when they deposit, they will settle down under the effect of their own weight, but due to the like which I told you in the previous slide, that there might be some sort of plus and minus charge on the particles. In case of finer particles, the charges also play some role, in what happens there. The surface electrical forces prevent these solids to roll down into a new state of equilibrium. They were going to settle according to the weight. So, one particle here, then other here, other here, but the surface electrical charges is trying to prevent it. This surface electrical charge may be positive and the above one will be maybe negative. So, they or both may be positive, so they will be repulsing each other. So, instead of getting into a single grain structure, they will try to form some voids, and how they will be formed, we will be looking on to that. So, these prevent these solids to roll down into new state of equilibrium, holding these solids in the clusters of honeycomb, that we have told, that I have told you in the starting discussion, that how can a honeycomb be there, like this one or this one. So, honeycomb enclosing large volume of voids in between them. Let us see the figure here. So, see here in this this one here figure, the solids are there, but due to some due to gravitational force that is also acting, so they will be trying to be in contact with each other, this one here, but due to some repulsion this void is being formed. So, they includes what, a large number of voids. So, it is dependent on what, the soil structure. The finer the soil structure, we are getting more dominant the surface electrical forces that are preventing them to just collide and just settle according to each other. So, the next here, the flocculent and dispersed structure, the third portion. This structure is for fine clay and colloids, wherein the surface electrical forces are predominating. So, fine clay and colloids, the very first thing we discussed, that was what? That was about the surface, that is the gravitational force being the dominant one. Now, when we are talking about this thing, the second one, honeycomb structure, we discussed that it was due to the surface electrical forces and gravitational forces both. Now, here in the third one, we will be seeing that the particles here are finer and the surface electrical forces are dominating over the gravitational forces, that is they are more. So, clay particles in an aqueous medium. So, these are very much fine particles, very much fine particles, very small particles. So, the clay particles in an aqueous medium may be mutually attracted or repulsed due to the surface electrical forces. Let us say there are some plus minus and let us say plus sign. We also know that fine particles are what, are having some sort of flaky nature. Flaky nature means it is having a dimension which is very much, one dimension is very much less, it is very small. So, it is having this type of dimension and it may carry this sort of charges in there on the surfaces. So, we will be discussing how they, and if say here, if another thing come here, then this particle, it might contain this minus charge, and if this minus charge is here, so it will be attracted, but in case it would have been plus, then it would have repulsed it. So, we will be discussing that. So, understand here, if the total potential energy between the particles decreases as they approach each other, so if the energy is lesser, they will try to what, there is a attraction between them. So, they will be collaborating, so they will be coming towards each other. So, here the particles approach each other and they flocculate. Flocculate means they are coming together in flocks. Secondly, in the flocculent structure, the particles flocculate essentially in the edge to phase direction, although I am saying this essentially in the edge to phase direction, but although edge to edge and face to face flocculation are also possible. So, there is a possibility that it might happen that edge to edge and face to face also happens. We will see in the diagram this. Secondly, if you are talking about this dispersed structure, it gets formed if the approaching particles have more energy, are occupying more energy. So, it if the approaching particles increases the potential energy of the system, then they will moving apart, that I told you here, if they are of same particles, so they will be like highly unstable. So it will be increasing the potential energy of the system. So that will be of the case of dispersion, and dispersion of the particles will mostly in the phase to phase direction. So this phase to phase, like I will be telling you this phase to phase and edge to phase thing in the figure, so that it will be easier for you. This, see here, this dispersed one, first of all, this is the phase, this is one phase, this is another phase. So these are the phases, herein phase to phase interaction is going on. And similarly, see here, this one dispersed, let us say here it is plus sign, here it is minus, and there it is plus. So if it is plus and minus and then this plus, or if we say this plus, this minus and then this plus. So here in this case the opposite charges will attract each other. So it is what, one's edge, this one is edge and this one is what, face. So edge to face interaction is more, but here we see this also, edge to edge also being common here, but it is not a very much common here. So this thing here, it is edge to face, this one is a common, a general phenomena that is being observed in these type of structures, but this thing is rarely observed. So both we cannot control and each and everything. So it, as the structure is in nature, so it can also be possible. When we go for the properties of the flocculent and dispersed structures, we will be seeing that flocculent one will be having higher permeability. See here, the passages will be more, So when the passages are more, there will be more permeability. Second, see here, the in the dispersed structure, that the passages will be not too much, like if there are passages, but when you are talking about this flow or this flow, it will not be able to match the flocculent structure. Similarly, there will be higher shear strength in the flocculent one, because the particles are when you are discussing about the particles. So in the flocculent structure, see here, the shear strength will be higher. So and when we talk about this thing, these are very much having low shear strength, because the cutting tendency will be more, we can easily cut through the soil in the dispersed structure, and in flocculent we cannot be able to, because there are more volume of voids. So we have to dismantle the structure and then we will be able to reduce the shear strength of the flocculent one. See here one thing more, that the dispersed will have the lower compressibility, dispersed one will have this one will have the higher compressibility. See, if the dispersed structure is having this type of structure, so when we are compressing it, when the load is being applied, so it will be compressed to a larger extent. But when this flocculent structure, it is like this or this or this or this one, so this will be this voids will be trying to push the load or take on the load, or the voids may contain water which we consider as incompressible, so they will be trying to take on the load. So the examples are, this one will be marine soils show this kind of flocculent structure, and the lacustrine soil that is found in the lakes is known to show the dispersed structure of the soil. So here we have discussed the soil structure, and one thing I need to point out, that when we talked about these things, see in these three examples, in these three structures, we told you that there can be a small grained particles or a larger grained particle or the much larger particle. So we talked about the particles, but in actual there can be what, coarse grained and fine grained both. So when there is a composite soil, so it can having two types, like when there are more than two, like coarse grained and fine. If coarse grained particles are more, or if fine grained particles are more than coarse grained in a particular soil, so what happens, that if we say their coarse grained is more, so what happens, that in a particular volume, major portion and the interparticle contact is between this one coarse grained particles, but the fine grained particles also are acting here. Fine grained particles are filling the voids. So here see one thing, the fine grained particles are very much smaller in number. So this coarse grain will be in contact with each other and fine grain will be occupying the void spaces in between them. So it will be a low compressible soil, because this force of this will be resisted by this. So it will be low compressible soil, because the bigger particles will be trying to occupy the spaces. When we talk about this fine is greater than coarse fine grained fraction, so if we say that in a particular volume there is one coarse grained, another are fine grained, let us say this. So it is major portion is what? Fine grained. So fine grained will have a tendency of taking up higher loads. When the load is applied, so it will have a tendency of absorbing the load, and so it will having a what? High compressibility. So these are the two structures of the composite soil. The first one is named as coarse grained skeleton, because the coarse grain provides what? A skeleton type of structure, and this second one is named as cohesive matrix structure. Okay. So these, with this topic we end the soil structure portion. Now we will be moving on to the next topic of this, wherein we will be discussing the clay mineralogy. In clay mineralogy, see here that it consists of two fundamental building blocks that are arranged in definite orientation in the clay structure. So let us say there is one unit this and this one. When the clay minerals are formed, these two units form the basic structure, form the basic unit or the fundamental unit of making that structure. So like when you write a sentence that Sahil is a good boy, so when you don't know the alphabet, S-A-H-I-L, Sahil is a good boy. So these are type of fundamental blocks for understanding a word and then framing a sentence. Similarly, when we talk about this thing, silica or octahedral, it is the fundamental block, the very first basic thing which we will be understanding, and these will be helping in forming a clay mineral. So let us discuss this thing. The very first unit will be silica tetrahedral unit, wherein a central silica cation is surrounded by 4 oxygen anions. Central silica cation is surrounded by 4 oxygen anions. So you already know that it is having plus charge, plus 4. One oxygen will be having what? Minus 2 charge. This will be at each corner of the tetrahedron. Let us say this is a tetrahedron. Understand this here. This one here is the base. Consider here as a base plane. Let us assume it is a tetrahedron base plane, and above is the one oxygen atom. Let us see here, this one here. Also understand here, this base plane will be containing 3 oxygen atoms. One can be here, one will be at the back side and one will be at the front side. That these 3 are on the base plane and one is above. In between this 3D figure, there is one cation, that will be silica, having charge of plus 4. And the second point here, it is given that net negative charge is -1 as sharing of oxygen atom takes place, and it is symbolically represented by trapezium. So understand this, that when we will be showing a simplified figure, here a 3D figure is given, and when we show a simplified figure, it will be what? A trapezium. And similarly there will be one symbol for octahedral unit, we will be seeing that. You see here, when we are talking about this base plate, this one, so each oxygen atom will be shared in the backward one and this left side one and either the front one. So each is shared by 3 oxygen atoms, shared by 3 units. So if you are taking the charges, how the net negative charge is coming in there. So, understand that there is a plus 4 charge of silica, minus 2 of 1, because one oxygen atom is not getting to get what? Not getting to attach to any other atom, only the 3 base ones will be getting attached. So, see here, that one will be not getting into formation into any structure, so that will be minus 2. Other 3 will be sharing their charges, so each minus 2 will be divided into 2 units. So, that will be minus 1 and minus 1 for 3 oxygen atoms. So, resultant is plus 4 minus 2 and then minus 1 minus 1. So, it will be what? Minus 1 negative charge. Now, going on to the next topic here, octahedral unit. When we discuss this octahedral unit, here 6 hydroxyl ions enclose what? Aluminium or magnesium or some other metallic cation in the base plane at the center of the octahedral geometry. See here, if this is a base plane, so one point is here, second is here, third is here, fourth is here, and one is at the top and one is at the bottom. So, see here, how is an octahedral unit formed here? This is one is the top, these 4 what constitute a base, and this one will be at the bottom, and this blue one will be any metallic cation. It can be aluminium or magnesium or Fe2 plus or Fe3 plus. So, we will be discussing that thing. See here, the green ones here are the hydroxyl ions, OH minus ions. Now, these OH minus ions, how they will be like trying to affect the total structure charge. So, we will be seeing that thing. See here, when we discuss this topic, so each hydroxyl ion is trying to form different, and they are trying to attach to different units. Here 6 hydroxyl ions encloses aluminium or magnesium or some other metallic ion, that is Fe2 plus or Fe3 plus in the base plane at the center of the octahedral geometry that I showed you in the figure, and each hydroxyl ion is shared between 3 octahedral units. Let us say this one is 1 unit, so this will be shared to 1 and then 2 and then 3. So, how it will be affecting the net charge on this octahedral unit. So, this I have told you, this M2 or M3 plus, that is aluminium or magnesium, that we will be seeing here. So, see here that here when we are talking about this, if the cation enclosed is aluminium, so resulting sheet will be what? Gibbsite, and the cation enclosed is what? Magnesium, the resulting sheet is brucite. So, what are their characteristics, how the charges is plus 1 or 0? See here that when we are saying that 6 hydroxyl ions are shared between 3 units, so it will be having a minus 3 charge. If there is aluminium, that will be plus 3, and when there is magnesium, there will be plus 2 charge. So, it will be this one minus 2. So, the resultant charge will be what? Minus 2 and this plus 1. For magnesium it will be what? 0. So, these are the resultant charges. So, with this we come on to the next thing, and we will be discussing it in the next class, wherein we will be discussing how these things will be affecting the clay mineral, the basic units. Thank you.